Hello, everyone, and thank you for joining today. My name is Jeff Peoples. I'm a Senior Product Manager here at Parasoft, and today we're going to be talking about how to level up your test automation using some of the new features in Parasoft's 2021.2 release. Let's cover a bit of housekeeping before we get started. If you have any questions, feel free to drop them into the Q&A box, and I'll get to those at the end of our session. Because we won't have time to cover all the enhancements and changes in the new release, I'm going to cover the main ones, and then I'll leave you with a link that will direct you to docs.parasoft.com, which you'll be able to find the release notes for all the products, and you can get details on these and the other great updates we've made in our latest release. So before we begin, I'd just like to give you an overview of the automated testing world using a diagram you may have heard of. The testing pyramid, which was popularized by Martin Fowler, and it's designed to show you where you should be spending your time and how many tests you should be running at each layer, which we at Parasoft wholeheartedly agree with. At the base of the pyramid is a foundation of unit tests backed up by a solid set of API or service level tests. These tests are more efficient, so you should have more of them to achieve broad coverage. It's best if they are done earlier in the SDLC because they're easier to automate, understand, and ultimately easier to diagnose any root causes of test failures. At the upper half of the pyramid, the best practice is to focus on seeking opportunities to automate whatever is manual, to test back-end functionality directly with APIs, and focus your UI testing on client-side logic and user journey, as UI tests are difficult to automate, they take longer to run, and you have to wait until the entire application and the test environment is available. They're also difficult to maintain and difficult to diagnose when defects occur. So maybe when I said I wholeheartedly agree, I may have been a bit too hasty. See, we at Parasoft believe there's a missing layer to this pyramid, which is at the code level. You can't build quality into an application by doing a lot of testing. You need to have a quality-first approach during requirements and development and code analysis to help address the deep reliability and security issues and can help you identify and prevent those problems from occurring in the first place. Following the pyramid as a blueprint helps you create a test automation strategy that is scalable for enterprise applications. Everything in the testing pyramid should be used to validate and verify code and address defects within the use cases. However, when we talk to actual organizations, most of them have what may look like an inverted pyramid or an ice cream cone or perhaps something like a martini glass or a thick Game of Thrones goblet. And this is because 90% of the projects we're introduced to are not greenfield development and where best practices can be applied from day one, but rather they're brownfield, where teams are struggling to modernize a process or a project that's been around for a while. And when we dig deeper, we see that it's actually worse. We find that many organizations are skipping right past the API testing because it's hard to understand, or it often falls into this no man's land between dev and test roles or teams. And the bottom line is that many organizations are still struggling with achieving automated testing and extending that to continuous testing. So a typical API testing scenario using Parasoft's continuous quality platform would involve determining which parts of the application we want to test and the steps that we need to fully test our APIs. And after that, we set up our monitors and our proxies, and then using Parasoft Recorder, we record those action steps and then leverage our smart API technology to generate API level tests for those actions. Let the AI handle the heavy lifting. Then it's possible to focus on your API testing directly. And it's at this point that I wanted to add that version 2021.2 allows you to shift your API security testing left or begin API security penetration testing during the development phase. Now, let's take a sidebar here for a moment to explain. Why would we want to shift left, this buzzword we hear about? Basically, what we're talking about here is shifting left the identification of defects and API security vulnerabilities count as defects to earlier in the SDLC where they cost less to find and to fix. Now, this chart was first defined in 1996 by Capers-Jones, and it's still relevant today. We're only doing it faster because we're agile. So most software defects are introduced during the coding phase of development, but most defects are found during the later stages where it costs much more and is more risky to fix, find, and remove those defects. So what we're focused on doing is shifting left the identification of defects earlier in the SDLC by leveraging earlier stage quality practices such as deep code analysis, including secure coding practices and unit testing, which also has the effect of reducing the number of defects introduced in the first place by training the developers as they go. And taking those tests that are created during the later stages, i.e. the functional performance and API security tests, and executing them continuously as new capabilities are added to the application, essentially doing regression testing continuously. So in addition to being able to shift left some automated API security penetration testing, you can also add a test to your test suite to validate an OpenAPI Swagger definition. And I can show you why that's helpful in a minute. And not only that, we've enhanced the reporting with some changes that I will demonstrate later. So how do we virtualize? Virtualization is typically a 5-step process. You have your application under test here that your developers have been working on, and you have your testing tools. You have SOA tests, and you have load tests for performance testing. And the application will have back-end resources that it will have to access, like databases or REST or SOAP services or even other applications. Now, our first step is to define monitors or proxies that intercept the communications between our application and its back-end resources. These resources have API traffic flowing between them, and Parasoft's recorder gives you the ability to capture that. So next is to now go about the steps we want to take in our test while pointing at that live resource, recording those responses. We then collect that information, those transactions and data, and we use them to create our virtual asset. And that virtual asset includes responders that will return data in the same way that the live resource responded to those same exact requests. And Parasoft Virtualize does all of this for you, and they can be completely customizable or as ultimately simple depending on what you need. And I'll demonstrate creating these later in our demo. Now, with version 2021.2, you have the ability to create virtual asset skeletons using OpenAPI Swagger documents. So if you don't have the recordings available to you, then a significant part of the setup is taken care of for you, and I'll demonstrate that later as well. And whether you used OpenAPI or you generated your virtual assets from a recording, the next step is then to deploy our virtual service to our Parasoft Virtualized server. Now, this is the point where most virtualization solutions stop, but there's a key component here, and that's the orchestration of those virtual services. So how do we control our virtualized assets once we've deployed to our virtualized server? By using our Continuous Testing Platform, or CTP. CTP is Parasoft's web-based interface where we take an environment-based approach to testing, where you can graphically define your specific topology in a model that you can then save configuration instances that are combinations of on or off or live or virtual, and then toggle between those live or virtual assets for your particular testing scenario. Much of the same functionality in CTP is accessible via API to enable you to manage your virtual assets and testing in a CI/CD pipeline. And new with 2021.2, you can now configure your CTP jobs to send the results to DTP. And you now have the ability to register SOA virtualized servers, whereas previously it was a view-only screen to check their statuses. We all have some kind of CI management process, like Jenkins or Azure DevOps, Bamboo, GitHub, any of these different platforms. And using CTP, we can coordinate the activities of these proxies that were first used to record the traffic to now redirect that traffic to our virtual services. And the last enhancement I wanted to cover is that we've simplified the steps it takes to run test impact analysis. So what is test impact analysis, or TIA? So you have your user stories, and you have your tests, and you have your code. With work item based execution, we have a link between our user stories and our tests. So we know that when a particular test fails, we can trigger problem reports for those user stories, depending on which tests fail. Time and resources can be conserved by only running the tests related to the user stories that we worked on during the given sprint. But TIA takes it to the next level. The AI analyzes the code to understand the links between the tests and the code itself, and it is then able to detect which parts of the code have changed, and focuses on running only those tests associated with the code that it detected changes for, saving you valuable time and resources in sprint. Of course, you still need to do full regression as you near the end of the sprint, but with TIA, you don't have to do it every time. Or what's more likely, you don't have to skip in-sprint testing and thus create a fire drill situation come the end of the sprint. Here's the entire process in summary. We begin our work with work item requirements in Jira, and we develop solutions according to them. We record ourselves as we test the functionality. As we save our recordings, we link our user stories with our tests. At this point, we allow our Smart API technology to generate those tests from those recordings. And we collect this information in DTP to determine our code coverage and verify application quality meets your company standards, from which we can then generate the necessary remediation work items in our work tracking application, and the whole process starts over. For CI builds, you can use test impact analysis to get quick feedback on application changes mid-sprint. So it looks like we've come to our demo. I'm now going to take you through an example where I'll begin with already having used Smart API technology to generate a simple test, and from there we'll cover our new seamless integration with OWASP Zap to enable you to add penetration testing to your existing functional tests, really enabling you to achieve that shift left API security testing in your development process. I'll then demonstrate the use of the new OpenAPI specification validation test, and then we'll use that same OpenAPI file to generate the foundational framework for building a virtual asset. And then I'll show you how to configure your CTP to push job results to DTP, and then show you those results in DTP. So now let me flip to my browser. Okay, what we have here is the back end of my online store so that I can see when I have submitted a new order. Now, to save time during our demo, I have already gone through and I have used Parasoft Recorder for Chrome plugin to record my actions and my API traffic. And I have generated API tests from that API traffic. And so we can go to, this is Parasoft SOA test. And if I come to my test assets and drop this down, and user anonymous there. Okay, this is the test that I have generated. So each time I run this, it's going to create a new order in that back end. So what I'd like to show you before we get into this is our smart API technology isn't just doing a record and a playback of hard-coded values. Okay, so let me just drop this down, and we see this right here. And what this is that the smart technology has examined those responses that came back from the server, and it has detected when a value can be implemented as a dynamic variable, and then it captures those and it saves them into what we call a JSON data bank, so that later down the line, and I believe this is a good example, where we see both hard-coded values and these dynamic values. And what this is saying is use these other hard-coded values, but then for this particular ID value, I want you to use whatever returns from test 3. These are therefore linked dynamically, and the underlying data could actually change, but the test retains its integrity. And let me see, I have another one down here. So if I drop this down, and we see here we have that JSON data bank again, and then we have also a JSON asserter where the application has detected, yes, this is a dynamic variable, but that variable needs to have a value of X. And so obviously trying to create all of these tests manually with the underlying data model and the dynamic variables that are linked together between tests. To do this all manually would take a very long time, but it's simply, I just went through my test process, which took about 1.5 minutes, and saved it, and it generated all that for us. We'll just do some house cleaning here. What I'd like to show you next is what we refer to as our native penetration testing support added to SOA test. So what we've done to support penetration testing is that we have seamlessly integrated with OWASP Z Attack Proxy, or OWASP ZAP. And to add penetration testing to my existing functional test, I can either come up to the test suite, right click it, and say add multiple outputs, or I can hold down my control key and select the specific test that I want to apply penetration testing to, or I can just click the one that I want. So I can actually right click here and then select add an output, and right here it has response, request, or both, and I will add a traffic object to both, where I'll click that and I'll select penetration testing tool and I'll click finish and close that. And if I drop this down, we now see that I have added penetration testing to my currently existing functional test. And then to run it, all I would do is come up to here, right click, and say run. And so while this is running, what is actually happening is ZAP is launching all of these, what ZAP refers to as policies, which are attacks on our particular service. And you have the ability to configure these with a ZAP configuration file, or you can just choose the defaults, which you see listed here. Okay, so now we see that it's done. Now the benefit that we have to applying penetration testing to our existing functional test is that you now have the ability to create a complex scenario that can be processed through to get your data into a state that's the ideal test point for penetration testing. So let's look at our vulnerabilities. We see here that we have 10 tasks reported. So I'll just drop this down and we'll look at it. Okay, look, it says we have buffer overflow scenarios, cross-site scripting weakness vulnerabilities, and here we have HTTP verb tampering. Now I can double click here and we see the explanation right here. I wanted to specifically point out verb tampering because Parasoft SOA test has extended the ZAP functionality and improved upon the verb fuzzing. I can also run a report here. So I can click here and then tell it run report. And this report has an all new layout. And though API coverage isn't new to 2021.2, I'll go into it just to explain it. And what this is, we're not talking about code coverage. We're talking about the application has analyzed the APIs exposed by the server, and it has determined from our tests which of those APIs were touched. And so we can see here that some are completely tested, some haven't been tested at all, and then we see here partially tested with the red for the failures that we saw for those particular penetration tests. So I can also scroll up here and I'll click API security issues, and this will take us to the new API security section of the report, where we see we have this chart which shows high, medium, or low risk or informational risk level as opposed to high, medium, or low confidence level. And the confidence level represents how likely this is not a false positive and that how likely this is in the code. And the risk level indicates high, medium, or low severity that should be addressed. We see here we have HTTP verb tampering, and we can click that, and it'll take us to the section that explains verb tampering to us. We see we can view our traffic, and we also have external resources such as CWE's website, the Common Weakness Enumeration, on a particular classification of issues, of which verb tampering is one of them, and as well as the OWASP link itself for verb tampering. So I'll just close out of that. So the next thing I wanted to show you is validating an open API specification. And we'll just add this to our existing functional tests as well. So to do this, we start at our test suite and we right click and we select add new test. And this screen pops up and we have our choice of standard, setup, or teardown. It doesn't matter for this particular test. We just select standard. And I'll just select from my list here, OpenAPI Swagger Validator. So I'll click that and I'll click finish. And here it prompts me to provide a OpenAPI file. So I have that one. I'll select it, click open. I'll save that by clicking the disk icon over here, save, close that. And now I can just run that specific test. So I'll right click it and say test. And it found no issues. So that is a valid OpenAPI document. Now the question is, why would you want to validate your OpenAPI? Well, the reason is that we have the ability to generate the skeleton for a virtual asset. So let's go back to our online store for a second. And so here we have the back end of our online store, and we see that each time I run this test, it actually accumulates orders. And so we have a situation where each time we create an order, we're actually decrementing inventory in the live system. And eventually, I could run out of stock. And so the first thing I want to do is virtualize this asset so that's no longer an issue. I'm going to use my valid OpenAPI document to now create a virtual asset. So to do that, we come over to Parasoft Virtualize. And we click Virtual Asset and right click and add new virtual asset. And now it's just asking us what we want to name it. So we're going to call this Open API App. And then we'll click Next and generate parameterized messages. So I'll click Next. And here, my definition type says Open API Swagger. Now, normally I could provide a traffic file if I had that, and it would generate this whole thing according to that traffic file. But in this scenario, if I didn't have a traffic file, I would use my Open API Swagger file. So I'll just select that and select my Open API file and click OK. And then I click Next, Next, Next. And then here we see it has created responders for each of the items that it found in that OpenAPI spec. So I'll just click Finish here. Great, so we've now created our OpenAPI app. So I'll just come to here, drop this down, and we see all of the responders that were created. Now this is the framework of the virtualized asset. If we had had actual traffic, we could build the actual responses, but because we had only the Swagger file, the framework has been set up with all the links and the data links to the data sources. And so we can just come here and, like, for instance, we'll double click cart items get. And so we see that data model just like we saw with the JSON data bank. And we see parameterized form values that we can fill in these values to generate the responder that we particularly want. All this has been set up for you, and it read them all from that OpenAPI specification. Okay, great. So we come back here. I'll just close that up. Close that. And the beauty of running your tests is that they can be run 3 different ways. They can be run with the SOATest desktop app. They can be run via REST API, or they can be run with Continuous Testing Platform, or CTP. This is CTP, our web-based environment manager for managing our virtual assets and running our tests. And I'll just drop this down to better describe our example. So what we have here is that whether we're using a web browser or whether we're using SOATest, it doesn't matter, because either one, we're hitting the online store server, which is accessing these back-end web services. Now, I have imposed this proxy between the server and its back-end service, and then implemented my virtual asset here. And the proxy acts as a traffic cop. When it sees requests coming from the server, it says, rather than go to the web service, instead go to my virtual asset. And this is a very simple model, but there could be complex models with various combinations that can all be saved into these configuration instances, and all it takes to flip between your virtual and your live asset would be to click here and click provision. And so as that is running, we see here that it is actually running my demo app test here. And I can provide an entire suite of tests for it to run. Okay, so that was successful. So now if we go back to our online store backend and refresh, we see that no orders exist. So we're no longer accumulating orders because we've now virtualized this asset. I can run this test as many times as I want, and I'm no longer facing that issue that eventually I could run out of inventory. Success. Okay, so I can run my tests from the diagram by provisioning, or I also have the option of running via the API testing screen. If I click here on SOATest servers, Prior to 2021.2, this was a read-only screen where all of your SOATest servers would be listed out and you could reference here to find out their statuses. But with 2021.2, we've added the ability to now add a server. And I would just enter my server name, my host, my port, and my credentials, and I would just click confirm. In this case, I'm only running on localhost, and so I only have the one server. But your new server would be listed right here. And if you needed to add more, you would just reference this plus icon. So to run my tests from CTP, I just come to test scenarios and I'll click there and we'll see here's my test waiting to be run. Now I could just click here and click execute and that would run the test. But what I wanted to show you is this new feature added in the latest release, which is published to DTP. And so if I put a check in this box, it now prompts me, it asks me for my project, my build ID, and my session tag for DTP. Now, the project I'm using, I'm calling What's New 2021-2. And the build ID and the session tag default in with these values. So I'll just click Save and execute. And so now it's going to run the test again, and it's going to finalize the results and then publish them to DTP. And so we see that it's passed. So now let's go to DTP. Okay, great. So here we are in Development Testing Platform, or DTP, and we see that we ran 32 tests in total and green all the way around, so everything was successful. And then here's where the last run that I did, it was processed. Publishing data to DTP from CTP is another of the new functionalities that was implemented in 2021.2. So to review, we started with our native penetration testing support, which is our integration with OWASP ZAP. This is a seamless integration with OWASP ZAP, and ZAP is packaged and installed with SOATest, so you don't have to worry about setup or configuration to get ZAP to work. And talk with your representative if you'd like to add penetration testing to your current package. We covered the validation of an open API Swagger file and created a virtual asset skeleton framework on which you can build your responders. And then I showed you how you can configure CTP to push job results to DTP, and then we looked at those results in DTP. And since we have time, I'll quickly touch on some of the usability enhancements with the new release. I mentioned that we added the ability to register SOATest virtualized servers from CTP. We have added read operation to our native CRUD tool, which is very popular. I mentioned conceptually that we've streamlined test impact analysis and what that entails. I went over the report updates, at least for the API security report. You can now subscribe to receive emails whenever your CTP job's complete. And we made additional enhancements to the search and other usability enhancements. So I guess that about wraps it up. So we do have a little bit of time now, so we can go to the Q&A box and see if we have any questions. Okay, so our first question is, what kinds of authentication does SOATest support? Okay, SOATest supports basic and digest authorization as well as OAuth and NTLM. Those are the 4 types of authentication that SOATest supports. Okay, next question is, does Parasoft support load testing of REST APIs? Yes. The tests that you saw generated were TST files, and TST files are completely compatible with our load test product. Where did you go when you flipped to the list of penetration tests? Okay, I went to docs.parasoft.com, and that was under the section for penetration testing. Okay. How does Virtualize handle stateful use cases? Okay, stateful use cases can be done one of two ways. And one, the more complex solution is full CRUD, where you have your data maintained in the data repository, and that can perfectly maintain the state, and you have full create, read, update, delete functionality to completely add data on the fly exactly how you need it. As I said, that's a more complex solution. Another way is with our sequence responders, which can actually mimic a stateful sequence, but you have to have the same calls and the same data in the same order. Those are the two methods to handle stateful use cases. Okay, so that does appear to be all of the questions that we have. For details on any of these and any of the other enhancements that we did to 2021.2, please visit our website at docs, as in documents, docs.parasoft.com. And I also like to invite you to attend our upcoming Automated Software Testing and Quality Summit scheduled for November 4th. This half-day event will feature companies from multiple industries that are sharing their continuous quality journeys. You can find more information and register at the link shown or scan the QR code. To request a personalized demo of anything you've seen today, just submit a request at our website. And be sure to check out our website for other great resources such as white papers, case studies, and our blog. Thanks, and have a great day.